explain about the group theory. In this group theory, I am going to explain about the basic things, that is the introduction of the very basic group, and basically I am going to explain two things. First is binary operation and second is algebraic structure, and after that binary operation laws. So first of all, we will know what are the groups. If we talk about the groups, then group theory, then we can say group theory is the most fundamental concept of modern algebra. So this is the fundamental concept of the modern algebra. We need to know about the modern algebra, then we need to know first group theory. And if we talk about the groups arise naturally in various mathematical situations. So there are so many mathematical situations where these groups arise. If we see the applications, we talk about the applications, then they are found in physical and biological sciences, particularly for the study of like crystal structure. Crystal can be used to study about the crystal structure, and second one is configuration, molecule, and third one is human genes. So these are some applications in which we can see the groups, or we can say if we want to study the algebraic structure, then this is the starting point. This is the starting point to know about various algebraic structures. So we want to know the algebraic structure, then we need to know about the group. Now we will see about the binary operations. So now we will see that what is binary operation. Binary operation, normally we know that plus, minus, multiplication, that we study in programming languages. Those are the binary operators, but here we will study about the binary operations, and these binary operations like plus, minus, multiplication, dot, they behave in some different manner, because we are going to explain with respect to the group. So if we talk about this binary operation, it means we are talking this binary operation with respect to the group. So plus dot operation multiplication, these symbols, so we can say symbols are used to denote the binary operations in group theory. Now, whatever we can say, if we are having a group, let G be any set, then G cross G is equals to A comma B. We are taking a set, this is G, then G cross G is equals to A comma B. This is ordered where A belongs to G and B belongs to G. Now let us consider a binary operation. This is F, then G, F is such that G cross G gives G. It means we are making this operation by using some binary operation, and after applying the binary operation in the same group, we will get some element that will also belong to G. For example, we can say if A comma B belongs to G, then A, this is any operation, operation B, it gives C. Then this C also belongs to G. Or we can say if we are using multiplication, A multiply B, then this will belong to G. In this case, we can say this binary multiplication is the binary operation. If we are applying the binary operation between these two elements and we are getting third element that also belongs to the group, then this is known as the binary operation. So F is known as binary operation on some set G. Now we know that symbols plus multiplication, these are used to denote the binary operation. Some other symbols are also there. So if we can take any example, plus is used to denote the binary operation, or this is binary addition. So we are saying that this is denoting the binary addition. So now if and only if A comma B belongs to G, or A plus B also belongs to G, and A plus B is unique, Means if we are taking two elements A and B that belongs to G and we are finding the A plus B, in this case this plus this binary addition is known as the binary operation on this. So this is known as binary operation. This is known as this plus is known as binary operation on G. Now we can take any other example. This is example 2. This is multiplication. This is the binary operation on a set G if and only if A multiply B belongs to G. For all A comma B belongs to G and A into B is unique. So this belongs to this and this belongs to this. This is also for A comma B belongs to G and this is also unique. So we have discussed two binary operations. Moreover, we can say these two examples, example 1 and example 2 are known as closure property. Closure property means this plus and multiplier, they are closed with respect to some G. So this is closed property. So plus and multiplier are two binary operations closed with respect to some G. Or we can say this set, this is closed with respect to plus and multiplication. Further, addition and multiplication are the two binary operation on a set N. This is the set of all natural numbers, or we can say this set of natural numbers is closed with respect to the addition and multiplication because sum and multiplication of any two elements, say A and B, also belongs to the set of natural numbers. Then in this case we can say N is closed with respect to plus and multiply. So this set of natural numbers is closed with respect to the addition and multiplication. But subtraction, if we talk about the subtraction, is not a binary operation. This is not a binary operation with respect to n, because if a comma b belongs to n, let us suppose there are two elements that belongs to a set of natural numbers, and these are a and b. Then a minus b may or may not belong to n, because for example, if we take two elements, this is 5 minus 9, so this does not belong to n, because from here we are getting this is minus 4 and this minus 4 does not belong to n. So here we conclude that plus and multiply, these are the two binary operations, but subtraction, this is not the binary operation. Moreover, now we will see about the algebraic structure. The next topic of group theory is algebraic structure. Algebraic structure is also very important because the concept of the group originates from algebraic structure. So this is algebraic structure. Algebraic structure is nothing but this is any set together with one or more binary operations. So any non-empty set together with one or more binary operations is called algebraic structure. For example, set of natural numbers for this, set of real numbers, set of integers for the multiplication, set of real numbers for addition and multiplication. These are the algebraic structures. So if we can take it as this is n comma plus, this is any algebraic structure, this is algebraic structure, this is algebraic structure with addition, with binary addition. This Z, this is set of integers, this is algebraic structure with multiplication. And third one is this is r comma plus multiplier. This is any algebraic structure with binary addition and multiplication. So, on the basis of binary operation and algebraic structure, we define the definition of the group. So, group is nothing but it is any algebraic structure that holds some property, that is known as the group. And we very well know that in group there are normally 4 properties, that is closure, associative, identity element, inverse element, and fifth one is commutative property. From commutative property where we say that it is abelian or not abelian. So this is about the binary operation and algebraic structure. Moreover, we can also see the binary operation laws. The laws of binary operations. Laws of binary operations. The first law is, this is associative law. This law says a binary operation is closed, or we can say this binary operation is associative. A binary operation is associative if A, B, C belongs to any set, and we have A into B into C, this is equivalent to, we have taken here the binary multiplication. We can also say, if we generalize it, then it can be written as like A operation B operation C is equals to A operation B operation C, like this, but we have taken here binary multiplication for the simplicity. So in this case we can say binary multiplication, this is the binary operation and this is associative. Second is commutative law. A binary operation, is said to be commutative if A multiply B or A operation B, this is equals to B into A. For generalization, we can write this A operation B equals to B operation A. So this commutative law, this binary operation is commutative in this case. Now we will study about the identity element and the inverse element. So identity element and inverse element, these are also the two properties which are necessary for the group theory. So first we will see the identity element. Identity element, if E, B and identity element that belongs to any set, then in a set, then A into E equals to A equals to E into A, where A belongs to G. This is any set for all A. So any element in G is known as the identity element if this property holds for all A. This is identity element, and other is inverse element. Inverse element is also very important property of the group. So any element if A, B, any element that is A belongs to G, then if A multiply B equals to E equals to B multiply A, if we have such type of situation where we are having any element that is B and we are multiplying with this A and we are getting the identity element, then we say this B will be known as this will be the inverse of A, and denoted by, it can be denoted by A inverse. So here we have supposed that B is the inverse of A. Then if this is inverse of it, then A multiply B equals to E equals to B multiply A, or it can also be rewritten as A multiply A inverse equals to E equals to A inverse multiply A. So this is inverse property. Moreover, one more thing is left, that is additive inverse and multiplicative inverse. So now it is to be noted let R be any set of real number. This is any set and A belongs to R. Let us suppose that A is any element that belongs to R and 1 is the identity element in the set. Now if A plus minus A, this is equals to, this is 0, this is 0, this will be 0. So we will have A plus minus A equals to 0. This is known as additive inverse. This is known as additive inverse. And let Q be any set of rational numbers and A belongs to Q and 1 is the identity, 1 is identity element, then if A multiply 1 upon A equals to 1, this is known as multiplicative